Hello guys, so today we will continue with a very new topic under the divide and conquer strategy, that is quicksort algorithm. So it is one of the important sorting algorithm which is used in very practical situations. Okay, so let us start and understand the concept thoroughly. Quicksort. So basically it is one of the application of divide and conquer strategy. First of all, so what is divide and conquer strategy? It divides the bigger problem in terms of what smaller problem, or other way of saying it divides the given problem in some smaller problems. Then recursively it solves the sub problems and find out the solutions, and finally combine the solutions to the sub problems to find the solution for the original problem. Okay, तो इसको ये डिवाइड एंड कॉन्कर स्ट्रेटजी है. Next, then it is what? It is an in-place sorting technique. So in previous lecture, I told you that what is in-place sorting technique? That if in any kind of sorting algorithm, if we are not taking any extra space, okay, apart from the given array or given space, then that algorithm is called as in-place sorting algorithm. ओके, सिंपल मीन्स अगर हम कोई एक्स्ट्रा स्पेस नहीं ले रहे हैं देन इट इज इन प्लेस, और अगर हम सॉर्टिंग करने के लिए कोई एक्स्ट्रा स्पेस ले रहे हैं दैट इज इट इज नॉट इन प्लेस. ओके, एंड व्हाट अबाउट स्टेबल एंड नॉट स्टेबल आई विल explain at the time of what algorithm explanation I will show you. Okay, and it is very practical, so it is used in practical situations. One more important thing is that the quick sort is what given by Tony Hoare. Okay, so maybe some mistake is there, but okay. Name is Tony Hoare. So he is the developer of what this quick sort algorithm, and he received Turing Award for that. Okay, Turing Award. Okay, for what? For quick sort. So it is very popular algorithm, quick sort algorithm. Okay, so let us see. So quick sort. So there are basically three steps because it is one of the application of divide and conquer strategy. तो पहला क्या है कि divide the given problem into some smaller sub problems depending upon pivot element. So what is pivot element? So it is, there is one algorithm, that is partition algorithm, which plays a key role or important role in quick sort algorithm. सो दैट इज पार्टीशन एल्गोरिथम. पार्टीशन एल्गोरिथम क्या करेगी कि एक पर्टिकुलर एलिमेंट को पाइवट एलिमेंट सेलेक्ट करके और उसको अप्रोप्रिएट प्लेस पे उसको प्लेस कर देगी. डोंट वरी, आई विल शो यू हाउ दिस एल्गोरिथम इज गोइंग ऑन, है ना, एंड एक्चुअली हाउ इट वर्क्स. Okay, so divide the given problem into smaller sub problems depending upon pivot element. Don't worry, I will show you what is pivot element and partition. Next is apply recursively to get smaller subproblem solutions, to get subproblem solutions. So just do the recursion again and again to get the uh, solutions of the subproblems which we achieved in the previous step, or which we what formulated in the previous step, that is divide. Okay, now finally we are having the solutions of our subproblems, and finally combine all of them to get the original problem solution. So this is the general DAC approach. Okay, so these three points is nothing but it is a DAC approach, divide and conquer approach. So generally this thing only we do in the divide and conquer approach. Okay, now the very first partition algorithm. Okay, so partition algorithm, as I told you that it plays an important role and key role in the quicksort algorithm, है ना, बहुत ही मेजर important रोल है इसका partition algorithm. So let us see how this algorithm works. So this is the starting and ending of this partition algorithm. Okay, so what is that in this is A is what? A is array. So this is the given array, and this is the start index. P is the start index and Q is the last index of the array. I will show you with the help of example how this algorithm is going on. है ना? So in the very first step, what they are showing that P is the first index or start index. Start index के element को हम X में store कर रहे हैं, okay, और I को हम set कर रहे हैं starting index पे, और J का loop run करेंगे हम just what one element ahead, एक element आगे, है ना, कहाँ से, जहाँ पे P point कर रहा है, P mean next element से, okay. एंड इन द लूप वी आर चेकिंग वेदर जो अपकमिंग एलिमेंट्स हैं वो एलिमेंट अगर लेस हैं किससे, हमारे एक्स एलिमेंट से जो हमने सिलेक्ट किया है, तो हम आई को यहाँ इंक्रीज करेंगे और साथ में इंटरचेंज करेंगे ए ऑफ आई और ए ऑफ जे को. सो दिस एल्गोरिथम विल वर्क, है ना, एफिशिएंटली. सो दिस इज द इफ पार्ट एंड this is the for loop. And after one such for loop, okay, after the completion of this particular for loop, फाइनली क्या होगा कि जो हमारा a ऑफ 1 है और a ऑफ i है उसको हम क्या कर देंगे, इंटरचेंज कर देंगे. वाई a ऑफ 1, बिकॉज हमने फर्स्ट एलिमेंट p जो है ना, फर्स्ट एलिमेंट, उसको हमने क्या सिलेक्ट किया था, एज अ पाइवेट एलिमेंट सिलेक्ट किया था. सो आई होप दैट दिस इज क्लियर. नॉट एज ऑफ नाउ, लेट मी solve a problem, then it is very much clear. Okay, let us suppose this is your array A and this is your P and this is what, this is your Q. Let us understand very carefully. Okay, so what we are doing in this algorithm, that starting जो भी value है, that is we are storing in x. So we are storing x equals to 65. Okay, means this we are selecting it as x. Okay, now what we are doing next, so next I equal to p, तो यहाँ मैंने i को सेट किया. so this is selected as I and for loop रन कर रहे हैं हम, तो for loop रन करेंगे j equal to p plus 1. so j equals to what, p plus 1. so p plus 1 is going to be this, so this is j. okay, अब हमें चेक करना है कि अगर a of j जो है लेस है x से, हमने x पाइवेट एलिमेंट सेलेक्ट किया है. okay, तो this element we selected as pivot element, so this is pivot, this element is selected as pivot element. तो हमारा a of j क्या है, 70, which is not less than, so just move ahead. next j comes here, so this loop is running. okay, this is loop. so loop में क्या चेक कर रहे हैं कि a of j अगर लेस और इक्वल है x से, तो हमें i को इंक्रीज करके उनको इंटरचेंज करना है i और j को. ओके, तो यहाँ भी नहीं है, a of j is not less than means 75 is not less than equal to 65. so just increase this j, so increase this j to this particular point. so this a of j is 80, 80 is not less than 65, so just increase this j again. so j will come here and a of j is 85, 85 is not less than 65, so just move one more ahead. okay, now a of j is 60 and x is 65, so 60 is what, less than 65. so what we are supposed to do, i को हम increase करेंगे पहले, so just increase the i, so i will come here, और a of i और a of j को क्या करेंगे, interchange करेंगे. okay, that is written in algorithm, interchange inside the for loop, interchange a of I and a of j. so finally this place will be what, 60 and this place will be what, 70. so this is the first replacement. okay, now after that just increase the j again, so a of j, so a of j is what, 55, 55 is less than x, so this pivot we are just checking with pivot element. okay, तो ये लेस है, लेस है तो हम उस केस में क्या करेंगे, i will be incremented, not this is not I, this will be I this time. so I will be incremented and a of I and a of j will be interchanged. so यहाँ आ जाएगा आपका 55 and this place will be occupied, replaced with 75. fine, so j further फिर increase होगा, loop is going on. so a of j is 50, 50 is less than pivot element, so again I will be increased, so I को हम increase करेंगे यहाँ पे और a of I और a of j को interchange करेंगे. तो यहाँ इस place पर आ जाएगा 50, है ना, और इस place पर आ जाएगा आपका 80, so this will be replaced with 80. okay, fine, next time j will be incremented, so j हमारा पहुंच गया है ना at the end, तो a of j कितना है, 45, 45 is less than our pivot element, so just increase I and interchange a of I and a of j. So increase I, A of I and A of j will be interchanged. So this 85 will be replaced with 45 and this 45 will be replaced with 85. Okay, so finally ये loop complete हुआ and after the loop what is there? After the loop जो हमारा पाइवेट एलिमेंट हमने सिलेक्ट किया दैट इज ए ऑफ वन और ए ऑफ आई, इन दोनों को क्या करना है? इंटरचेंज करना है. ओके, सो ए ऑफ वन इज व्हाट? ए ऑफ वन इज 65 और आई क्या है? आई है. तो फाइनली हम इसको और इसको इंटरचेंज करेंगे. सो दिस 45 and 65 will be interchanged. So here it is 45 and here it is 65. Okay, and I को हम return करेंगे. So see here, I we are returning I. So again, if you observe carefully, I am writing it again. So what will be the solution? So it is 65, it is 70 and not 70 and not 65. All the values are changed. Okay, just write the updated value. So what are the updated value? First value is 45, next value is 60, then it is 55, then it is 50 and then it is 65 and then it is 70, then 75, then 80, then 85. So see the beauty of this algorithm. Now I is this, so we are just returning the I index. Okay, so if you are observing carefully, then what all these elements are less than 65, less than 65. So this is the beauty of what this particular partition algorithm. Partition algorithm फर्स्ट जो हमने जो भी यहाँ पाइवेट एलिमेंट सिलेक्ट किया था वो उसको उसके अप्रोप्रिएट प्लेस पर फिक्स कर देगा, है ना. उससे लेसर वैल्यू वन साइड होंगी और ग्रेटर वैल्यू, है ना, अदर साइड होंगी. सो दिस इज greater than 65. Okay, so this index will be returned. So it is so this particular value will be returned I. Okay, now let us solve one more problem, then it is very much clear to you. So what is going on? I will do one by one, okay, so that it is very much easier to you people. So first, what is this? This is P starting. So this is the array A and this is what P and this is what? This is Q. Observe carefully. तो फर्स्टली हमने क्या किया कि A of P को X में स्टोर कर दिया. So pivot selection. So X equals to what? 25 एंड यहाँ हमने I को सेट किया और लूप रन करेंगे नेक्स्ट ऑफ P. सो नेक्स्ट ऑफ P इज दिस. सो A of J is less than 25? No. So just move this. Okay, A of J is less than 25? No, because pivot is our 25. So just move this. A of J is less than 25? No. 38 is not less than 25. So just move it. So this A of J. A of J is what? 11. 11 is less than 25? Yeah, of course. So finally what we are supposed to do? I को increase करेंगे. So I will be increased. So now this time 25, 57 and 48 and 38, 11, 90 and 89 and 29. So I will be incremented. So I यहाँ आ जाएगा आपका और J is where? J is this particular location. This is J. और A of I और A of J को क्या कर देंगे? Interchange. So this 11 will come here and 57 will go there. So this will become now 57. Okay. Finally, your X is what? X is here 25 only. Okay. Now just increase J. So J this. A of J is 90. 90 less than 25? No. Just iterate the loop. A of J is 89. 89 is not less than 85, 25. Just go one more. So 29 is not less than 25. So finally this is over. So after this over, then the first value, that is the value pointed by this particular P, okay, or the first value and ith value will be replaced. So what is the ith value? Ith value is this one. So finally these two will be replaced. So these two will be interchanged. These two will be interchanged. Okay, so what will be the resulting result? 11 and 25. and 48 and 38, then 57, then 90, then 80, and then 29. So see the beauty of this algorithm. Now this is what, this is your I. Okay, so this, okay, so this is the beauty of this algorithm. So I am writing here that what is this element? This is pivot element. So partition algorithm, okay, will, so partition algorithm places pivot element to its, okay, to its correct place, correct and place, that is all elements lower than that are on the left side and greater than that are on the right side. Okay, so this is the beauty of this algorithm, and finally it will return the index of that particular element. So it is clearly observable that this partition algorithm is taking what, how much time? So it is taking order of n time, because just iterating a loop, that's it, nothing else. Okay, so the time complexity, so the complexity time complexity for time complexity of partition. So the time complexity of partition is what? So it is order of what, n. Okay, so it is order of n. Now come to the actual quicksort algorithm. So quicksort algorithm, what we are supposed to do, this is the quicksort algorithm. So this is the initial condition or termination condition. This is initial condition, initial condition. So A is the array and P is what, P is your start index. Okay, P is your start index, and Q is what, Q is your last index, last index. Now observe carefully that if the problem is small, means only one element is there in the array, so then P double equals to Q, so simply return Q, that's it. Okay, nothing else. Otherwise, else, so this is the else statement. Partition algorithm, so partition algorithm will what, call return what, the position of the pivot element. Okay, correctly placed pivot element. So m means m से लेफ्ट हैंड साइड में सारे स्मॉलर होंगे और m से राइट हैंड साइड में सारे लार्जर होंगे. तो m फिक्स हो चुका है, तो अब p से m-1 तक हमें पार्टीशन कॉल करना है, क्विक सॉर्ट कॉल करना है, और m+1 से q तक करना है ना. तो दो है ना, टू पार्ट्स में डिवाइड हो गया हमारा प्रॉब्लम, है ना. सो देन दिस पर्टिकुलर time taken by this partition is what, order of n. Okay, and time taken by this is what, t of depends, it depends. Okay, so how it depends I will show you. Okay, so it is best case and worst case situation. So that अगर partition ने दो half में divide किया है n/2 में, so then this time taken will be what, t of n/2 and t of n/2. Otherwise some different positions में divide किया है, then it depends. Okay, so let me introduce one more thing. So this is a question. So the question says that quick sort is applied on the following two inputs. to arrange in ascending order. So the first one is 10, 20, 30, 40, 50, 60, and up to n. Some n numbers are there. So if you are observing carefully, then all these numbers are in ascending order. So this is ascending order, and these all numbers are in descending order. If you are observing descending order. Okay, and question says that let C1 and C2 be the number of comparisons made for the input 1 and 2. So this is input 1 and this is input 2. So C1 and C2 are the comparison made for input 1 and 2 respectively. Then what will be the relation between C1 and C2? Okay, तो क्विक सॉर्ट एल्गोरिथम अप्लाई करना है. सो क्विक सॉर्ट एल्गोरिथम में कितने कंपैरिजंस होंगे? तो जब हम फर्स्ट केस में अगर हम बात करें, फर्स्ट केस दैट इज द वेरी फर्स्ट इनपुट, तो यहाँ जब हम क्विक सॉर्ट अप्लाई करेंगे तो पार्टीशन जो है वो कहाँ देगा? 10 को 10 के ही प्लेस पे देगा, फिर नेक्स्ट टाइम 20 को 20 के ही प्लेस पे देगा. तो जितने नंबर ऑफ कंपेरिजन लगेंगे वो इसमें भी सेम होंगे और इसमें भी सेम होंगे. ओके, बिकॉज असेंडिंग के केस में क्या होगा कि एज इट इज पार्टीशन वहीं आएगा. डिसेंडिंग के केस में क्या होगा कि एन किससे रिप्लेस होगा? वन से. तो वन और एन एक दूसरे के प्लेस पर रिप्लेस हो जाएंगे. नेक्स्ट टाइम एन माइनस वन और एन जो है एक दूसरे के प्लेस पर रिप्लेस हो जाएंगे. सो दैट काइंड ऑफ phenomena is there. Ultimately there is no changes in the comparison. Okay, both will compare same times and same number of comparisons are there. So finally we can say that uh, there is always C1 equals to C2 because number of comparisons are same. Number of comparisons are same in both cases. Okay, both cases, number of comparisons are same in both cases. So that is the thing. Now what is the time complexity of quicksort algorithm? So worst case time complexity. So what is the worst case time complexity? So worst case time complexity means if what array is already sorted. Okay, if array is already sorted, okay, in any order, in any order. Okay, that is ascending or descending. That is ascending or descending. ओके, सो किसी भी ऑर्डर में हो. सो क्या उसमें चेंजेस आएंगे कि लाइक फॉर एग्जांपल 10, 20, 30, 40 एंड 50. सो दिस विल बी द फिक्स प्लेस फॉर पाइवट. और रिमेनिंग एलिमेंट्स कितने होंगे? रिमेनिंग एलिमेंट्स विल बी n minus 1. सो दीज n minus 1. ओके, एंड पाइवट एंड पार्टीशन. So partition will take what? Order of n time. Okay, and this is the time taken by this. So in this case, what will be the recurrence relation? Recurrence relation will be t of n equals to t of n minus 1. So what is this t of n minus 1? जो n इनपुट की प्रॉब्लम के लिए टाइम लग रहा है हमारा t ऑफ n, तो n माइनस वन इनपुट्स जो हमारे असेंडिंग और डिसेंडिंग वट एवर है ना, तो n माइनस वन इनपुट्स के लिए लगेगा t ऑफ n माइनस वन. और n क्या है हमारा यहाँ पे? पार्टीशन टाइम. ओके, पार्टीशन टाइम. So now solve this particular recurrence relation. So this can be solved by substitution method. So just put the value here and plus n. So what will be the value? If you put n के place पे n minus 1 put करेंगे, so this will be n minus 1 and plus this in place of n minus 1. So finally this will be t of n minus 2 plus n minus 1 and plus n. नेक्स्ट टाइम अगर आप पुट करेंगे तो यहाँ क्या आएगा? t of what? t of n minus 3 and plus what? n minus 2 and plus n minus 1 and plus n. So if you repeat this how many times? हमें यहाँ 1 चाहिए. ओके, सो 1 के लिए हमें कितने टाइम्स रिपीट करना पड़ेगा? n minus 1 टाइम. So this will be repeat n minus 1 times. Why I am saying n minus 1 times? Because यहाँ n minus 1 रखोगे तो वैल्यू आएगा 1. see this, I'm doing this. So n minus, so n minus 1 this, ओके, एंड प्लस यहाँ 3 था तो यहाँ 2 से स्टार्ट हो रहा था, n तक जा रहा था, ओके। यहाँ n माइनस 1 है, तो यहाँ कहाँ से स्टार्ट होगा आपका, यहाँ आपका n है ना, माइनस 1 मीन्स लेस देन 1, सो यहाँ आपका आएगा कहाँ से, t of 3, so it is 2 है ना, and n minus 0 n minus 1 till n minus 2, so this way यहाँ पे क्या आ जाएगा, n minus 2, okay, or simply you can write it as, so like this, n minus 2, okay, n minus 1 and n, so this way this and this gets cancelled out, so this is t of 1 and plus like this, so it is 2, and like this, so it is n minus 2 plus n minus 1 and plus n, so finally t of 1 का वैल्यू कितना है, 1, so 1 plus 2 plus up to so on so forth up till what, up till n, so this way you will get 1 to n natural numbers का sum, so it is n into n plus 1 by 2, so this is the value of your t of n. So finally in terms of time complexity, what will be the time complexity of this particular algorithm, t order of n square, because n into n is order of n square, so highest term is n square. So the worst case time complexity, so this is the case what, worst case time complexity of this particular algorithm. So worst case time complexity of quicksort algorithm is what, order of n square. So when this algorithm will give its time as worst case, when the given what array is already in sorted order, whether it is in ascending order or in descending order, okay. But this may not be the case in all the practical situations, okay. Let us first analyze best case time complexity. So what will be the best case time complexity, so in this case, uh, if partition will break the list, or if partition will return the index, will return the middle index of the array, middle index of the array, okay, something like that, key input is your, uh, let us suppose 10, 8, 6, okay, and 5, and suppose 12, and suppose 18, okay. So this way, finally after applying, so you will get like 10 will be placed to its correct position. So what will be the answer in that case, like 5, 8, 6 and 10, let us suppose this will maybe the answer, okay. So this is the pivot element, so this n by 2, okay, and this side also almost n by 2, so two halves में divide कर रहा है, okay. And partition algorithm, so partition will take order of n time. So finally this recurrence relation is what, this recurrence relation will be for best case, so it is 2 times t of n by 2 and plus n is for what, partition, okay. So this you can easily solve by anything, so let us solve this also by substitution, so like this plus n, so what will be the result, it is 2 and t of n by 4, so what is n by 4, n by 2 square and plus, so in place of n it is n by 2, so if you multiply this, so this will be 2 square t n by 2 square plus this 2 and 2 gets cancelled out, so it is n plus n, so finally it is what, it is 2n, so we can say 2 square into n upon 2 square and plus 2n, And similarly this way we can follow what k times. So if I repeat this particular process k times, then what will be the result? It's 2 raised to the power k, 2 raised to the power k into t of n upon 2 raised to the power k, and finally this will become 1, and plus it is k n. So if you solve this particular relation, what will be the relation? Like so it is n upon 2 raised to the power k equals to 1. So 2 raised to the power k equals to n, and k equals to what? Log n. So 2 raised to the power k, so this is n into this is t of 1, and plus this is n into value of k is what? Log n. So finally the result of this t of n will be what? N, because one value t of 1 is 1, n plus n log n. So what will be the maximum term in this? So this is order of n log. So this is the time complexity, but in best case. Best case. Okay, and also average case is also there, where sometimes you may get what, n minus 1 list, sometimes you may get some n by 2 list. So the average time complexity of quicksort algorithm is also same, that is the case of best case, that is order of n log. Okay, so this way finally, so basically all the times in practical situations you may not get already sorted order list, hai na? So that's why this algorithm is suitable in practical situations. That's why I'm saying that this is a divide and conquer strategy, and it is very beautifully designed so that it is best suited for practical situations, and gives the average case or best case time complexity is order of n log n. Anyhow, it the time complexity of quicksort algorithm is what, order of n log n, but uh, due to the what, mathematical calculation, or if the array is already sorted, then we will get it as what, that worst case time complexity is order of n square. Okay, so that is the thing. So I hope that this is clear to you people, and so this is what, this is about quicksort algorithm. Okay, now let us solve some problem. So first question is, after applying few passes of quicksort algorithm on the given array, we get the following output. तो क्विक सॉर्ट एल्गोरिथम के कुछ पासेस किए, यहाँ पे कुछ स्टेप्स किए, उसके बाद ये आउटपुट मिला हमें, है ना? सो दिस इज द आउटपुट sequence. Then how many pivot elements are there in the output? So firstly write this carefully. 1 10, it is 5 and 8, and then 15, and then 44, and then 55, and 30, and what, 70. So what is the role of pivot element? Pivot element means smaller elements are on the left hand side, and ना greater are on the right hand side. So कितने pivot element fix हो चुके हैं यहाँ पे? So let us observe carefully. So I think this 15. Okay, because less इस side है और greater इस side है, ठीक है? So lesser from this side and greater from this side. Okay, so this is the case 15. And what about others? I think 8 is also there, because less than 8 is this, not 8. This is not the case, not 8. Okay, because 44, 70 is also, yeah, 70, because less than this side and greater than this side. And what about others? And also 1, because less this side and greater this side. So these three are pivot elements. So 3 pivot elements. Okay, are on correct place. So this is 3 pivot element. Okay, and pivot element I already told you that what is the position of pivot element? means all the elements less than on the left side and greater than on the right side. So the ultimate answer for this is what? 3. Okay, so I hope that this is clear to you. Now let us move to a new question. So a few more questions are there. Okay, in the quick sort, the sorting of n elements, the n by fourth smallest element is selected as pivot using order of n time algorithm. So pivot selection, let us do this. Pivot is selected in order of n time, and it is given the n by fourth. Okay, so partition is what? Partition is again there. Partition is again order of n. Okay, so what will be the recurrence relation for that? Recurrence relation will be this is n plus n plus t of n by 4 and plus t of 3n by 4. I hope that this is clear to you. So this is for what? This is for what? Pivot selection. And this is for what? This is partition, and this is the list, है ना? So this can be solved with the help of what? This can be solved with the help of recursion tree. Okay, recursive tree method. Recursive tree method. So I hope that this is clear to you. N, so we are dividing it n by 4 and 3n by 4, and similarly this n is again divided into n by 4, so n by 4 square, and 3n by 4, so 3n by 4 uh, square. So this is again n by 4, so n by 4 means 3n by 4 square, and this is again 3n by 4, so it is 3 square n by 4 square. Okay, so which leaves will go to a maximum? uh, so n by, this is n by 4 dividing by 4, so dividing by 4, and this is dividing by n divided by 4 by 3. So this way we can say that, let me solve for, okay, for k times. So this is n by 4 raised to the power k, and this will go to some lower level, so n by 4 by 3 raised to the power k, which is finally goes to 1. Okay, so this is what? This is k times, okay. So here let me write this also in a beautiful manner. So this is what? Here it is n time, here also the overall time is n, here also the overall time is n. So overall time is what? So time complexity is what? So it is n k. So what is the value of k? So k will be calculated from here. So n equals to 4 by 3 raised to power k. So you will get k as log n base 4 by 3, this. So this way you will get what? Time complexity is order of n log n base 4 by 3. So this is the time complexity. Okay, so finally you will get this is the time complexity. So means you will easily say, you can easily say that है ना, कि pivot element selection of pivot element does not impact the time complexity of the quick sort algorithm. Okay, whether you select the n by fourth smallest element or some blah blah and some different things. Okay, ultimately it will not affect. Now let us solve one more question. So the question says the median of n elements can be found in order of n time. Okay, so which one of the following is correct about the complexity of quick? Okay, so pivot is again median. So median is selected in order of n time, and partition. So partition is what? Order of n time. Okay, so median means this way you can say that t of n equals to n plus n plus t of n by 2 plus t of n by 2. So this is similar recurrence relation, है ना? And if you solve it, this will also give I think same thing. So n is what? N is your pivot using median. This is what? This is partition, and these are the, है ना, n by 2 inputs. Okay, so finally this way you will get what? T of n equals to 2 times t of n by 2 and plus 2n. So if you apply the master's method, so it is what? It is n raised to the power log 2 base 2. Okay, so this will give me n, and which is equal to this function. Okay, so finally the time complexity is what? Order of n log. Time complexity is order of n log. Okay, so means I think you are getting that whether we select it as mode, median, and or mean, whatever way we can select the choose the pivot element, but it will not affect the what? The time complexity of the quicksort algorithm. Okay, because you can divide, but it depends. मीन्स एट लास्ट मैक्सिमम क्या हो सकता है वर्स्ट केस में कि अगर आपका एरे जो है वो ऑलरेडी सॉर्टेड हो, मीन्स n-1 में डिवाइड कर दे अगर वो. Okay, but in general case this will not happen. Okay, until the array is already in sorted and previously sorted. Okay, so let us see this also, randomized quicksort algorithm. This is an interesting concept in quicksort algorithm, randomized quicksort. So quicksort algorithm is same, but what is the randomness? Randomness is in the choosing part of the pivot element. तो अगर हम pivot element choose कर रहे हैं randomly, अभी हमने क्या किया था हमारे algorithm में? First element को pivot element select किया था. But if we are choosing the pivot element as random, okay, at random, then that particular quicksort algorithm is what? Randomized quicksort algorithm. So this is the very first point, that choosing pivot element randomly is called randomized quicksort algorithm. So one more beautiful point, that it is what? It is independent of what? Independent of input order. Input order आपका कुछ भी हो, whether they are what? In ascending order, descending order, but आपको randomly choose करना है ना. तो probability is high that the list will be divided in some halves or n by 4, 3n by 4, something like that. Okay, n-1 division is very rare. Okay, in that case, so no assumption about input distribution, no. And next is what? The expected time complexity of randomized quicksort algorithm is going to be what? It is order of n log. Okay, order of n log. And randomized quicksort algorithm will take what? Order of n square when all the elements are same. Okay, when all the elements are same, so like 10, 10, 10, 10, 10, and then only randomized quicksort will take order of n square. Okay, order of n square time. Otherwise, in any case, it will take order of n log n time. That's why the selection of pivot element at random is the best choice. Okay, so it depends. Okay, now one more important point related to that, whether quicksort algorithm is your stable sorting technique or not, because in the what we can say partition algorithm, there is one, if you remember, in partition algorithm, So this is the concept that less than equal sign is there. Means अगर हमारा less और equal भी है, then also we are interchanging. तो relative ordering उसका change हो जाएगा. That's why it is not a stable sorting chain. Okay. So quick sort algorithm, quick sort. So it is in place sorting, and quick sort algorithm is what? Not stable. Okay, because relative ordering of repeated elements, okay, elements changes before and after sorting, before and after sorting. Okay, and why this is happening, why this is going on, because due to what? Partition, due to partition. Okay, so I hope that this is clear. Now we are at the end of this lecture, and if you are getting all the things and liking the quality of content, then please like, subscribe, and share this particular channel with your learning community. So happy learning to all of you. Stay safe.